A very good evening to all of you, class 12. So, what is we are going to discuss today? I already have written conductance and conductivity, relation between J, sigma, and E, and resistance and resistivity, relation with tau, that is the relaxation time. So, let us begin conductance. So, by learning, you can study this or you can understand this. That conductance is relevant with resistance. Okay. So if minimum will be the resistance of a material, the greater will be the conductance of a material. That is why conductance is defined as the reciprocal of resistance. Okay. So conductance is the reciprocal of resistance. This is denoted by G, and G is equal to 1 upon R. So what should be its unit? The unit will be 1 upon R. So 1 upon ohm. So this will be ohm inverse. One unit will be ohm inverse, and one more unit is amperage. Okay, ohm. That is also unit, and Siemens as well. So you have to remember 3 units. One is ohm inverse, one we can say mho, and another one is Siemens. This is the reciprocal of resistance. Then you have to study conductivity. And conductivity is denoted by sigma. And sigma, it is defined as the reciprocal of. It is defined as the reciprocal of resistivity. Okay, so this is the reciprocal of resistivity. So reciprocal of resistivity is known as conductivity, and this is denoted by sigma. Sigma is equal to 1 upon rho. So students, if we substitute the value of rho, what is rho? Rho is equal to R A upon L. Once you will substitute this, so this will be 1 upon R A upon L. But you will get L upon R. And if you remember the unit of resistivity, what was the unit of resistivity? That was the unit of resistivity was ohm meter. So this will be 1 upon ohm meter. So this will be ohm inverse meter inverse. The unit of conductivity will be ohm inverse meter inverse. One more unit can be there. Ohm inverse is mho. So mho meter inverse, or we can say Siemens meter inverse. So these all are the units for conductivity. This is the reciprocal of resistivity. Please remember this. Now students, we are going to further solve few more things, that is relation between J, sigma and E. So relation between J, sigma and E. Relation between J, sigma and E. This is what we are going to study. Here J is current density. If I haven't taught you, then I can tell you here. Current density denoted by J. The charge distributed per unit area is known as current density. So current distributed per unit area, so divided by area. So its unit will be ampere per meter square. So that is current density. So we are going to derive a relation between current density, and this is conductivity and electricity. So if you remember one relation we have studied, the relation between current and relaxation time and drift velocity. Phi is equal to NEA dt. Now, if we substitute the value of Vd, what is the value of Vd? Vd is equal to E tau upon. Remember, I am taking only the magnitude. That is why I haven't written negative. Now, if I take this on the denominator, I upon A is equal to N E into E square, E tau upon n. So I upon A is actually current upon unit area is J. So J is equal to n E square tau upon n. If you consider singly here and E as here. So this is actually the reciprocal of resistivity. Resistivity is m upon n E square tau. And this is n E square tau upon n. So this will be 1 upon rho into E. But we know what is the 1 upon rho value? 1 upon rho. 1 upon resistivity is conductivity. So if we substitute the value of resistivity reciprocal will be conductivity. So J is equal to sigma E. That's a very fine relation. You have to learn this. Now students, this I have taken as rho. You should understand this. That why this value is equal to rho. So can we prove this value? This will be equal to rho. How we can prove this value? Because I have taught you in Google class as well. If you remember this, then you can help me out. So resistance in terms of relaxation time and drift velocity. How we can calculate this? What is the value of R? If you remember the value, resistance. R is the ratio of voltage and current. So R is equal to V upon I. Now students, what is the value of V? If we substitute the value of V, we know electric field is minus dV upon dr. So value of dV will be E into dr if we take the magnitude, and if we are considering the whole potential V, this will be equal to E into dr is the length, that is the length of conductor. So in place of V, we can write E into L. So here we are substituting the value of V. V will be E into L. So this is the numerator upon current. In place of current, can we write this as, if you once you allow me by my previous lecture, NEA V. So R is equal to E into L upon NEA. In place of VD, we can substitute E tau upon N. This is the value for drift velocity, the final expression, E tau upon N. Now students, you can see E into L. M is in divide and divide. So this will be a multiply upon and E into E will be E square and A E tau. Fine. This is the value of resistance. Now you can see electric field and electric field gets cancelled out. So resistance will be equal to ml upon n E square. This is the value of resistance. Okay. Now, if we have to calculate resistivity, so what is the formula for resistivity? Resistivity rho is equal to RA upon L. So that is resistance into area upon L. Now let us substitute the value of resistance. Resistance is ml upon n E square A tau into A upon L. So here L and L gets cancelled out, A and A gets cancelled out. So resistivity rho is equal to m upon n E square tau. This is the value for resistivity. And now if you correlate this here, n E square tau upon m, and there is m upon n E square tau. So you can well understand that this is the reciprocal of resistivity. That is why in place of here I have written reciprocal of resistivity, and I substituted because we know the reciprocal of resistivity is known as conductivity denoted by sigma. So J is equal to sigma A is a very famous relation, and I hope you understood that how we can calculate the resistivity of a material, and by this resistivity relation you can also get that resistivity is the property of a material. Here mass is constant fixed, number of electron, charge of electron, relaxation time. So all things are constant. That is why resistivity is considered to be the fundamental property of a material. I hope you understood all these terminologies on this chapter. Thank you for this.